Alrighty, Tommy Reed here. I want to give you a little update on this new YouTube channel. It is my old channel. I was able to at least copy the name. The TR Labs had a lot of contradicting other sites, and I did get some notifications about that, which is, it is what it is. So yeah, I lost a lot of videos. I took them all, but it's okay. It's my time, my money, and, but I'm always working on something. So sometimes a lot of people I know, they save a lot of my old videos, which is fine. That's not a problem. But I want to show you something that's very important with this. Now, this is a simple flywheel I have on this, a 20 kW generator. Yeah, it's a lot of power there, but the problem is people don't realize how much power it actually takes just to energize it. So this is a demonstration to show you the difference. This is a three-phase motor here. It's a 3600 RPM. Basically, you should run your motors at that RPM if they're rated, because once you start slowing them down, they're not that good for the motors itself. This is a single to a three-phase VFD, and we have it at 60 hertz. And basically, that's what we're going to run this right now. And right now, I'm going to just show you the energizing effect. And that is, how much power does it take to actually just energize the generator? And that's something that people overlook. You'd be surprised how much power it takes just to energize, because right now it's easy to spin, but once you get that up to a certain RPM, it's going to energize that rotor, and then once that rotor energizes, you're going to start producing power out of the stator itself. So it gives you a pretty good idea of the simplicity of it. So I'm going to start this up, and here we go. And I do have a 1500 watt heat gun to show you the difference of power. There is no free lunch on this. So let me get this going, and here we go. About almost 50 hertz. A lot of power there. Almost 2,000 watts of power. Okay, I'm going to energize this, and we're probably not going to be pulling the whole 1,500 watts, but just to show you what it is, here we go. Almost 3,000 watts. Let me speed it up a little bit more. Let me try to get this done right. Let me check this motor. Alrighty, let's set this up again. That's a lot of load. Let's set this up to about 65 or 70. Alright, there we go. Let's start this. turn on the heater again. That's a lot of power. Turn it off. Hertz. Try it again. Now that is a lot of power once it energized, almost 1700 watts of power, and that's not even pulling any power from the generator. What I'm going to do now is show you what the maximum power that motor actually pulls without a load. That way you can get a pretty good idea of how much energy it actually takes to energize these big generators. They're big. They take a lot of energy just to get them energized. So here we go. Let's start this up. And that's running the motor now. We're going to run that up to 60 hertz. And look at our power consumption. 140 watts. Not a lot of power. But I'm also not putting no mechanical work into it either. So it gives you a pretty good idea of the technical aspects of how these motors actually function. So I know, without a doubt, I'm going to at least waste roughly about 2.5 horsepower just to energize this generator. So I do have a diesel engine, a small one, but I think it's only a 3 horsepower, so I'm not going to get much power out of that, which will be a pretty interesting experiment, which I plan to do. But it gives you a pretty good idea of the amount of energy it takes just to turn this over to get it energized itself. Now, a lot of people would go with a permanent magnet generators. That's fine, but there's cogging involved. And if there is no cogging, here's the thing that people don't realize. It means it's going to produce a less power output. The greater the cogging, that means the greater the magnetic force it takes to get over that hump of a load, you're going to be able to produce more. A lot of these permanent magnet ones are not actually putting out a lot of power, especially if there's no cogging effect in it. Because you need that cogging. That's what they call magnetic saturation. That's where it's so saturated you can't really feel the cogging. But what you also get is far less power out of it. So this was a good experiment to show you the principle of what it takes to energize a 20 kilowatt generator. Now, even though I got a gear ratio going on, because this is 1800 RPM, and this is a 36, the flywheel's pretty close to where it needs to be, not exactly, but it gives you the idea that even with the leverage that I have, I still take a lot of torque to turn this over. So you got a little bit over 2-to-1 ratio. So even that will affect the amount of power. Now, the higher RPMs, the less load, but it takes a lot of power to get that up to the RPMs and stuff like that. So this is pretty much a little demonstration of how these generators need a certain amount of power. This is why you see an average of 5 kilowatt generator having over a 10 horsepower engine, so it can get over that hump. Of course, the smaller generators takes less power to energize. So I hope you enjoyed this little update. Tommy Ray, talk to you later.